Today on Coding 101, don't be scared, because we got your classes right here.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
Welcome to Coding 101. It's the Twitch show where we bring you into the world of the Code Monkey. I'm Father Robert Ballecer.
And I'm Shannon Morse, and for the next 30 minutes, we're going to get you all learned up on everything you need to know to be a C# code warrior.
Woot! I prefer the Code Monkey, but, you know, some people can be code
I'm
warriors.
going to make these people warriors.
Warriors, that's right.
And then we're going to have an army of coders.
That's actually kind of scary. I'm not really big on that. Now, Shannon, people have been getting a little freaked out. We've seen this in the feedback. We've seen this in the group. There are some people who are like, I still don't understand why we're doing this. Why do we have to go into classes? Why do we have to talk about abstract classes?
I don't blame them.
And I don't blame them. It can be a little scurry, but we're going to bring you all through some basic examples. We're going to bring you back to Module 1 of C# and explain why this really isn't any different than what you've been doing.
Yeah, I'll be honest, when I was writing my code for this episode, I was like, why am I doing the abstract classes?
Yep.
But I still did it, and I understand the functionality of it. It's just very hard for me to figure out why I would use it. But I think that's part of the problem-solving part of programming, is finding out why you would actually use certain things like abstract classes.
Precisely, and that's why we want to sort of slam on the brakes here, back up.
Hold up, people.
Slow down, show you a couple more examples, and then explain this is why this is important. I think one of the problems that we're running into is classes, abstract classes, and interfaces really become useful when you start creating much larger programs.
Yes.
We're writing very basic programs, which makes it difficult to see where it would come into play, but I'm betting that we're going to show you this week why this is the way you want to program.
Yay! Well, before we get started, can I do a little bit of snubs compiled?
I think so. Let's go compile some snubs.
All right, so hopefully you got my computer. I forgot to check beforehand. Oh, that's not my computer. That's it! Yay! So on my computer over here, I created a new program. Under here, you'll just see a little bit of code. And then over here, I had created a new class. So if you remember previously, to create a new class, you right-click on Snubs Episode 3 or whatever your program's called, go down to Add New, and then go down to Class. And then you add how many ever classes you want. So this is the class I created. And you'll notice right here, I made it public, so I can use it throughout the program.
Correct.
Abstract, so that I know that it's basically a drawing, an idea for my entire code.
Right, and actually...
That's how I explain it. It's an idea.
It's an idea. Actually, that's a very good thing, because remember, a class is like a blueprint, but a blueprint spells out exactly what you're going to build.
Yes.
An abstract, perfect analogy, is just an idea. It's like saying, well, I kind of know I want the building to look like this.
Yeah.
I have no idea what's going to go in there, but I want to make sure it has floors, it has windows, it has ceilings. That's it, right? And then you have to fill in the blanks later on.
Exactly. So back on my code, I just created to make an abstract class called food. Well, what is derived from food? Well, you have veggies, you have fruits, you have meats, you have dairy products. So under that, I created a public virtual string called type of food. And this is the one that's going to be get and setted. That's how I like to explain that part. And then I also had an abstract one called enter your food. So this is where if I was creating something where a person had to enter the type of food that they were buying, they could put in, okay, I'm buying a pumpkin or whatever.
Right.
And then under that, I also had one that posts a message. So this is similar to what Lou had showed us last week, where he did a social network one, and depending on if you have Twitter or Facebook or whatever, it could post some certain kind of message if you need it to pop out a message to the public, to all the consumers or what have you. So in mine, I just left that the same, and then under that, I had one that would return the type of food that a person actually bought. So this is very abstract. Obviously.
Right.
It's just an idea of one of the many things I could do. I could create this into a point-of-sale system so that every time somebody enters a barcode, for example, it pops out whatever kind of discount you get for that certain kind of food. Hey.
But it's still vital, because remember, when we start teaching programming, we really don't care about the code. The code is just syntax. What we're trying to do is teach concepts. And the concept here is break down the problem into little chunks that you can actually solve.
Yes.
And in your case, you created an abstract class. So there's, I mean, go back to our screen. If you look, in these methods, there's nothing.
Yeah, there's nothing there.
Right.
It's just a whole bunch of comments.
I know that I'm going to have those 4 methods.
Yes.
They're going to be part of my class. I know they're going to have to be what's called instantiated. They're going to have to be fully developed before they can be instantiated. This allows me to solve this tiny little chunk. What's the problem here? The problem is I need to have something that tells me the type of food, the name of the food, what I do with the food, and then, you know, et cetera,
I could change this to like recipes. It could pop out a bunch of different recipes that I want to use, or the cost of it, or whatever. And then down here, I created a type of food called veggie, and this one is a public class. So this is not abstract, so I actually had to add in some kind of code down here for it to actually do something.
Right, because remember, the abstract did not include what was actually in these methods. So you've done it now. By overriding, you've said, okay, you know that thing that you gave me before? This is what actually goes inside of it.
And it doesn't necessarily have to have all the other different ones in here because it's an abstract class that I started with. So I can just include the override bool one. So I override that and then I tell it to return the type of food or whatever. So it could do whatever I wanted it to. And then over here in program, you go over here and you see class program, and under that I have food number 1, new veggie. So I could make a whole bunch of different ones under here, all for new vegetables, or I could create a new class under my class over here and make it fruits, and then I could put a whole bunch of different fruits in my program, et cetera, et cetera, et cetera. So it could go on and on.
This is actually important. Remember this from the lesson 1 of this module. This is how you create an instance, an object of the class. So food, which was the name of the abstract class, num1. Num1 is going to be the pointer. That says this is where it's going to exist. So I'm calling it num1 is equal to new, which is a keyword. It means a new instance, a new object based on veggie, which you created from food.
And then from here, I could just, I could have them enter a kind of food, and I could have it pop out, you know, a return console write line when it says something back to me. Since this is a console application, I could have it do pretty much whatever I wanted to in here, as long as it's working off of this abstract class that I started with, this idea. Pretty cool.
But the nice thing is, the coding, so the coding for the class happens in a different screen.
Yeah, so it's very organized.
It's super organized, right? So now, folks, this is where it gets really, really cool, and that is...
And confusing.
And confusing. If I'm solving a problem, let's say I wanted to make a calculator. I need one class that solves for division, one class that solves for multiplication, one class that does subtraction and addition. Maybe I start building some classes based on some of the more advanced mathematical concepts. Now that I've got those built, I can use them in my main program without having to rewrite those methods. I just pull it in and say, okay, I'm going to use it in this way. I'm going to inherit these things, and this is going to be my object.
Oh, so cool.
Very cool. Are you going to show us what it does?
Oh, well, it doesn't really do anything.
Oh, not right
I didn't
now.
set it up to actually do anything.
Right, you just
when I
created
run it, I build it, and it didn't have any errors, so I know it was written correctly. But after this, I could make it do whatever I wanted to.
As Tyrrell says, the human class inherits from the monkey class. Yeah, okay, sure, that works.
So true. Okay, so I also had an example brought in from our Google Plus community, and this is from Nathan. Nathan decided to write something that will give you answers to a Fibonacci sequence. So pretty cool. So he was the one that was talking about you need to understand how to do problem solving to be able to be a good programmer. This doesn't have necessarily any class infrastructure in it other than just the main one that's included when you first create a program in C#. So if I build this, and then I hit start, you'll notice that it starts with a small number and then it goes up and up to a certain number at the end. Now I'll show you the problem that he shows us online. He actually linked to a example, not the right one. There we go. So he says each new term in the Fibonacci sequence is generated by adding the previous 2 terms. By starting with 1 and 2, the first 10 terms will be as such. So the question in here is, considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. So that's the whole problem solving thing that we're getting into. So that's a really good example. And then he also adds at the very bottom, Ha, that's my friend Jeff. Break all the things. Yeah. So down at the bottom, here we go. Okay, he says he has a challenge for newcomers. So this is a good one for you guys if you can figure this out. Below is a link to the code on GitHub, which is what I just showed you. Edit the program so that it will generate and add the even numbers, even values of the sequence all the way up to 4 billion. I'll give you a hint. It's easy, but it's not as easy as simply changing the upper limit variable. You might notice int will stop at a certain value. Interesting.
Yeah.
So good luck with that, guys. And you can find that over in the Google Plus community if you want to give it a try. And the last thing I wanted to share with you today for the Snubs Compiled segment is another thing linked from Mr. Nathan. And he said, check this out. I was up all night coding, so I'll just leave this here tonight. I feel like these language weapons are pointed right at me. So if programming languages were weapons. So let's find one that we've done. Here's Perl.
Perl.
It was probably useful once.
Perl.
But few people use
just
it now.
spreads out, causes a lot of damage.
And then we have JavaScript's pretty funny. Is a sword without a hilt.
Yeah, you're gonna cut yourself. Yep, I can deal with that.
Let's see, Python.
Bashes.
Double barrel shotgun. Only one barrel will shoot at a time. You never end up shooting the recommended one.
Also, you'll never actually hit the target.
And we also have C# in here. Here we go. So I like this one. C# is powerful laser rifle strapped to a donkey. When taking off the donkey, the laser doesn't seem to work as well.
Okay,
so
okay,
cute.
yeah, I'll buy it.
All in jest, of course, but very hilarious.
Well, it's important for programmers to have humor.
Oh,
so,
yes, I
thank
so
you.
agree.
Thank
but
you so
this was
much.
very cute. So thank you, Nathan, so much for sharing everything. You are one of my favorite code warriors of the week from our Google Plus community. And if you guys want to join, you can go over to bit.ly/twitcoding101 and feel free to join over there. We have over 1,400 members now.
Yeah.
Yay!
Now, we need to get into the ivory tower, but it's going to be a slightly different ivory tower. I don't want to spend a lot of time because I want to give as much time as possible to our code warrior, to Lou Maresca. But I do want to recap some of the things that we've talked about because people have been freaking out. We've been receiving emails from people saying, we don't understand why you're making us learn this, or is this the right time to learn this? Well, okay, we know that a class is a blueprint. We've talked about this. In fact, we just did. The blueprint spells out what you're going to create. Now, remember, a class doesn't actually exist until something instantiates it, turns it into an object. And we just showed you how you do that with the new keyword. Now, an abstract class is going to be like a blueprint, but it misses all the interior details. You're just trying to show the structure of the thing. An interface goes one step further, and it's just the outline. There's no methods, no nothing. In other words, it absolutely cannot be instantiated unless you write the entire program.
And Lou showed us an interface last week. It was at the very end of the episode, but he did show us an example.
Right. And the important thing to remember about this is people are saying, well, it's because you want to reuse code. Yes, that's it. You do want to reuse code, but there's more to a class than just that. When you do proper uses of classes, abstract classes, and interfaces, what you can do is to enforce a hierarchy, a signature of the way that you're going to program. This is important because even if it's a small program, even if it's just you programming on a particular project, when you need to go back later and figure out what you did, if you don't use the proper structure, if you don't have some sort of hierarchy that you've enforced, you will find out that you've created a Frankenstein. You've seen this, right?
I've seen Frankensteins, yes.
Yeah, where the code just goes on and on and on, and it's way down at the bottom. Someone says, oh, there was a problem at the beginning, I'm going to fix it here. It's difficult to figure out what they did.
You could end up breaking the entire program that way, too.
Precisely.
If you have it all on one page like that.
Whereas if you have a class, if you have a segment that you say, this class solves X,
yes,
then you know that if you have a problem with solving X, you know exactly where the problem is. It's in the class. It's probably going to be within the methods that you've included in the class. It's probably not in the instantiation of it.
I kind of just ran into a thing like this on a radio program called GNU Radio Companion, which is written in Python, but it gives you a nice little GUI, and you have to have different variables for different sample rates and frequencies and things like that. So as soon as you change that one variable, all your other little pieces of code, your boxes for your GUI, they all change automatically. So you're not going to end up breaking something in the process because it's all separated and they're just pulling from that one piece of code every time they need to change it.
Right. And it's just a better way to code. It's a better way to organize your thoughts. It's a better way to organize your code. And that's why we're teaching it. And that's why we're okay with freaking people out, because we know that in the end it's going to make them better code monkeys. All right. Now, let me show you a little something. Do you remember back in module, I think it was module 1, I think it was episode 1 or 2, episode 2, we did a problem where we had to convert a decimal number into binary.
Oh yeah, I remember that.
Right.
I don't remember exactly how to do it.
Yeah, what we did was we came up with a process. We said, okay, look, if you want to, it was easy to convert a binary into decimal because you just had to know the powers of the position and you just,
Yeah.
But if you want to convert decimal into binary, it's basically division. You start with a number, so you start with 7.
Okay.
You divide that number by 2. If you can divide it by 2, then that becomes a 1. It's an on position, and you move on to the next one. Then you write the dividend below the original quotient, and you write the remainder of the division next to the new quotient.
Okay, I remember that.
Right?
Yeah.
And you do that, and it's a very easy process, but you have to do it over and over and over again.
Right.
Well, what we did was we coded it. If you go ahead and go to my computer, Brian, you'll see the code that we wrote for that program. Very, very simple. And notice this. We were writing classes way back in module 1.
We just didn't know we were doing it.
We didn't know we were doing it, and we didn't tell people they were doing it because we didn't think it was important, because the programs were going to be so short, they were going to be so simple that it wasn't something we wanted to burden them with. You may remember we told you just don't worry about this part. Well, now what we're doing is we're telling you this is why we didn't want you to worry about it, because people are freaking out. However, if you did module 1, if you did these examples, if you did code these problems, then you have used classes. The only thing is that you didn't know you were using classes.
Surprise!
Surprise. Now, what we're asking you to do is to look at all the code from module 1, because it really will open your eyes as to how crucial it is to use classes and how easy it is. There is nothing that's different between writing a class and what you did way back when. The only difference really is going to be that you'll be able to get more organized. So for example, in this example, all we did was we solved for a problem. And the problem was, oh, sorry. I messed up my attaches. The problem was that it needed to solve for the simple mathematical question of how do I convert this decimal number back into a binary number.
Right.
It ran through the process, which is coded down here. There we go. And then we got ourselves an answer. Yay. So I want you to go ahead and go back through the, come back to us, go back through the code from module 1, turn it into classes, and here's the cool thing. Once you have them in classes, you'll be able to access them throughout your programming inventory.
It makes so much more sense now.
It really does. It really does. Now, to make it make even more sense, this is the part of the show where we're going to bring in our code warrior. Ladies and gentlemen, Mr. Lou Maresca. Lou, thank you for coming back in. I believe you've got one of ours with you. Is this some sort of hostage exchange?
Who is that?
What's he reading back there? Oh. The cookbook.
It's the C-sharp.
The ultimate C-sharp cookbook.
That's
fantastic.
Awesome.
Now, Lou, you've been listening into the conversation. You know that we've got people who have been freaking out. So what we asked you to do for this week of Coding 101 is to make the Code Warrior segment as simple as possible. Show them how we're making classes, where we're using them, and where it's advantageous to use them. Were you able to come up with something for that?
Yeah. So the example I'm going to give is a little bit more exaggerated than normal because we wanted to kind of prove a point that, you know, if you break it, you separate your concerns in your application with using classes, like Snubs and you've said, it's just always easier to maintain it after the fact. And so that's the example. And the example that I'm going to show too is going to kind of give you a more practical sense. I think what we chose is converting, doing exchange conversion. So like if you're going from euros to US dollars or something like that, and we're going to show a way to build that, and then maybe we'll build upon it later to pull information about like live exchange rates and stuff like that later on down the road. But this is just a primer to that, to building up to that. So if you want to show my screen, I can kind of give you the beginning part of it.
Let's do it.
So yeah, let's do it. So the first part is this is just the main program. I basically have collapsed everything so we can kind of see what's going on here. So I built a class over here to the right called currency. And it's a very simple class. Let me zoom in here for you guys.
A bunch of classes on there.
Yes, I built a bunch of classes. And like I said, I've kind of over-exaggerated it a little bit because I wanted to kind of prove a point. So this specific one, just called currency, and it has a currency code. And the currency code is just it's another class, but basically it's just a list of codes. So like USD for dollar and EUR for euro. So this is just a property saying a currency object is going to have a code with it. And it also is going to have a symbol. So like, for instance, an example would be like $sign as an example. So that would be a currency symbol. And then we also have this other little thing down here. It's an array of currency rate pairs. And it's another class that I'll show you. But all it is it's a rate to another currency. So for instance, let's say it's $1 for every euro, it's $1.29. So you'd be able to put in here, if this was the euro currency, you'd be able to put in here $1.29, and then the US dollar for as a pair, and then they'd be able to convert it. That's the simple class for currency.
Right. So each of these is going to do something specific. In this particular case, we want to know what kind of currency it is. We want to know what the symbol of that currency is. And then you have an array that will allow us to easily change any currency to any other currency.
That's right. So each currency, so think of it like this. It's if I'm a currency, let's say, I can actually know how to convert myself to another currency. Oh no! It's basically each currency itself is aware of another currency and its rate, and that's what that currency pairs is to say if I'm a euro, I have a list of other currencies like the U.S. dollar or the Canadian dollar and how to convert that. So it's making that class aware of how to do other things.
Okay, so I can imagine our audience saying, "But Lou, why don't I just put all that in one class like I did when I was writing the programs for Module 1? Why do I need separate classes for currency and for currency rate pairs? And I mean, why go through all that trouble? Why not just put it in one long program and I know where everything is?" Yeah.
So this specific example is a more simple example, but just think of it like this: currency is not just 3 properties. It's more than this. I just use 3 properties to kind of describe what it is, but there's more things in here. There's like what culture codes it belongs to, potentially what countries that use this currency, other things you can add to this specific class that are not in here. And sometimes it just gets way too complex, and it's really hard to kind of maintain that. Like, for instance, if I wanted to maintain a big list of countries and their currency types, I don't necessarily want to put it inside a currency because it doesn't make any sense.
Right.
So that's why breaking it apart is really important, because it's really what they call separation of concerns. It's just saying, I'm only concerned with these 3 things, and that's it. And that's how I want to kind of build my objects.
Right. And actually, if you could go back to your program tab, this is something that I think people need to see. This is his program. If you write your program correctly, it's so tiny. If you write it correctly, and if you separate out the concerns, if you have all your classes doing individual things, your program is not actually coding. Your program is saying, I need to calculate this problem, then I need to calculate this problem, then I need to calculate this problem. And that's what you get if you use classes, if you use the correct hierarchy.
Yep. So I kind of cheated a little bit because it looks tiny because I use what they call regions to kind of be able to collapse it.
But it's still tiny.
But it's still tiny. It's only like, it's a total of, I think, 60 lines because all the console stuff that I put in here to basically allow the user to enter the currency. But let me just show you real quick. So the reason why, I have a base type currency which has these 3 properties, but then this is even tinier. So I have an example of a US dollar currency. And you notice something, it's real tiny. There's like nothing in it. And that's because, like we showed before last week, is everything that I need is really in that currency type. Right. So what I could have done in here is, we don't want to get into this now, but there's things called constructors, and I can add everything into that constructor and set all the properties, and that would also go in here. But I did that instead inside the program, and we'll show you what that looks like later, and basically to initialize everything. But then we have a Euro version. Again, nothing in there other than just inheriting from currency. And again, I could put a whole bunch of stuff in here if I really wanted to, but I decided not to do that just to kind of prove a point. And then we have this currency rate pairs, and again, all it is a currency pair, meaning what currency is this and what's the rate. So is it USD and the rate's $1.29. So that's just the currency rate pair class.
Right. And actually, if you could go back to one of the currencies, one of the cool thing here is remember he's using inheritance. So he's making a brand new class for each type of currency. You've got the euro currency, you've got dollar currency. You could have Brazilian currency. But because you're inheriting from the currency class, you get the advantages of everything that he's already written for that class.
You don't have to rewrite it. It's already done for you.
Right.
You know it's not going to break because it's already
exactly. And as he said, he made this very small so he could give a better example.
Show it.
But
it's on the screen.
he could have included so many different methods and pieces of data for the currency. He could have, what's the current inflation rate? He could have, well, what is its current stability? Just look up the currency market on Yahoo Finance and find all the different bits of data that you can get about any individual currency. That could all go in here. And then when you inherit it to create a particular class for the dollar or the euro or the real, it will inherit all that information and it knows, oh, I need to use this to make it available for the programmer.
That makes sense.
Yeah, very nice.
So I built that, and then I also built this little other class, real simple class that basically will convert the exchange rate for you. Now you could, like I said, you could probably, some of the viewers are probably saying, oh, I could do that 10 different ways and probably even make it simpler than this. It's true. Again, I just wanted to kind of prove a point. There's just added a method in here that takes the amount and the rate, and then it returns the amount times the rate, and that's it. So if we go back to the program, here's an example of just creating an instance of that class. So we created we knew it up. We new US dollar currency. We initialized by setting the currency code and the symbol, and that's it. So now we have a US dollar one. We're ready to go. And then I also want to do that for euro too. So I set the euro and I set the euro symbol properties. And then now I want to be able to convert from euro to US dollars. And so I create this pair, I new that up, and I say, okay, what I actually want to go to is dollars. And so I'm going to set that as a property value. And this is the rate. So really simple, just setting properties, very simple code, no calculations or anything. And then this is the code down here. I spin up a new instance of the provider, the rate converter. And then in the code, this is all the console code, very similar code that we had all the way back to like episode 1 or 2. But again, all we do is say, okay, does the user number of euros that you want, write it out. And then we try to read that in. And if we read it in successfully, we calculate it. And then we write out the values. So very simple. So if we run this.
This is so handy.
Yeah, that's going to be kind of small.
I'm totally going to steal your code and use it for my trip to
make it bigger.
Tahiti.
Font bigger. Here we go. Okay, so if I put in that 20 euros is $25, in 80 cents US dollar, and it puts the symbol in there and the code for it too. So fairly simple code and very useful, like you said. And like I said, these is all static. So like for instance, I have the $1.29 is probably different now. If you go to Yahoo Finance right now, it's probably $1.29.5 or something. You never know. It changes all the time.
Right. But you could have constructed the class to actually reach out to an open API for currency information and pulled in real-time currency.
That's what this is for. Yep. So like I didn't put any code in here, but I put this as code for another day. But it basically, we could go out and get all the exchange rates for a specific currency type. And then we can return that as the array, and then store that inside the let's say euro. We can store it inside the euro collection of rates. So very simple. And it seems simpler because we've broken it apart. Now, if I could have done this in one big long program, it would have been. We could have done it just like all the other programs we showed you all the way up to episode 8. But would have been cleaner like this? Would it be easy to follow? Probably not. So that's the key. Is this is going to make it easier. And then as you get on and get more advanced, programs like this actually get easier to test too. So that's one thing that we're not doing right now, but it actually gets easier to test.
Right. Yeah. And that's one of the things that I've always known with object-oriented programming is rather than procedural programming, you can test individual pieces. So rather than just saying, oh, the program doesn't work, it could tell you, I'm not getting the right return from module dollar currency or euro translation, whatever you've created. And it makes it a lot easier to troubleshoot. It's one of those things that if you're writing a tiny little program, you may not notice. But even with something like this, which it has been deliberately made small, you should be able to see the advantages of having everything in modules. As Lou said, I think the challenge that we could give to the audience would be to take these modules and expand upon them. He's included 3 or 4 different pieces of data. Why not see how many more you can include in them? And then I bet you'll see the usefulness of using a class.
Oh, I love it. This makes it so much easier to understand when you actually see it broken up like that. It's so organized and it's so clean, and I think that's the biggest point of it.
And we're all about problem solving. That's what we want. And this is how you problem solve. You don't look at the entire picture and say, X, Y, Z. You say, all right, let's break it down into these little easy to digest pieces, and then we can code them.
I love it.
Yeah. Now, Lou, let me ask you this. Would it be useful to our audience to take something like this? Because towards the end of the Module 1, we did start looking at more advanced interfaces other than just the console window. To take this programming, to take these classes, and to show them how to actually turn it into some sort of app. Do you think we're far enough along that we could actually show that?
Yeah, definitely. You know, like I said, the reason why you're breaking it up into smaller pieces is that you can go plug it in anywhere. Like you said, I plugged it into a console app, but I could go plug it into any type of user interface I want. You know, in fact, this specific code is so simple that we could compile it down and even use it in like Xamarin Studio on Android device or an iOS device or something like that. So, I mean, it's so simple that we could plug it in any of those UIs.
Right. And actually, Dallas in the chat room wants to know if, well, do we have a real program that we could share these ideas? We use all these ideas. This actually is a real program. I mean, we're going to make this code available. The question is, will you take the code that we give you and expand upon it? That's the open invitation. We've given you some very simple classes. We've given you some very simple code that uses those classes. So expand. As we said, we've made it very small on purpose so that people can understand what's going on. It's your job to figure out how much more functionality you can get out of that code. Lou, thank you so very, very much. Can you give any parting wisdom to someone who may still be having a mini freak out on using classes, abstract classes, and interfaces?
Yeah, I mean, it's one of those things that when you build a class, the whole idea is you're kind of, like you said, problem solving. You're breaking it down to its base components, and then you're constructing it back up again. It's kind of like building Legos. You know, you select the correct blocks to kind of build the entire whole. And so those blocks are made up of all different shapes and sizes. And to me, those are like, excuse me, those are all different types of objects that you're building up another bigger, more sophisticated object. And the reason why they do that is they have molds for each block and their specific size. And that's exactly what a class is a mold for a specific thing, and then it can construct and build other things. And so that just, you know, when you're thinking about objects and building classes, that's really what it should be, is it's how to basically construct up and build bigger things out of smaller things. And then it's not so daunting when you think about it like that.
There you go, folks. Straight from
classes make it easier to make everything awesome.
They make everything awesome, and they make everything moldy, evidently. Lou Maresca, thank you so very much for being our code warrior again. I can't wait till next week because we are going to take this just one step further. We've heard your criticism, we've heard your critique, and we want to make this easier for you to understand. But remember, it is feeling kind of abstract right now because this is a Coding 102 module. We've already covered C# and the basics. We're now trying to give you something a bit more to become a better programmer. Lou, can you tell the folks where they can find you when you're not here on Coding 101?
Sure. LouMM on Twitter, and you can follow me about me, LouMM, and also all my works on crm.dynamics.com.
Fantastic.
Thank you.
Lou Maresca, our code
Thanks,
warrior,
guys.
we salute you.
Dun, dun, dun. Yeah, so Module 1 to me feels so much more like this is the syntax, this is how you write code. And Module 2 is so much more theory and idea. And
that's what it should be.
It's design.
It's design, right. We're talking about design now. Because remember when we did Module 1, there was so much of it that we had to say, just leave this here. Trust us, it has to be here, and then concentrate on the code.
Yeah.
We were getting them to understand basic constructs of computer programming. This is what a loop looks like. This is what a variable looks like. This is what a function or a method looks like. Now we're saying, forget that. You obviously have a grasp on what those pieces are. This is how the pieces come together into something that actually becomes useful.
Yay!
Yay.
I'm enjoying it.
Yeah, it's different, but
confusing.
It's good. Now, folks, we know that this was a lot of information. We're going to give you all the code. Shannon's code, Lou's code will all be in our GitHub.
Yeah, update the GitHub.
I know, it was my fault. And where can they find the GitHub?
twit.tv/code.
Exactly. Go there. You're going to find the show notes,
link?
which will give you the direct link to the GitHub, which will also give you the direct link to all the different modules. Now, I know some people were complaining that we only had module 1. That just means you've clicked on the wrong module. All 4 modules are in there, so you have to click module 4 to get to the right code examples. You can also find us on our Coding 101 Google Plus group. It's a good place to be because it's filled with experts and beginners. In other words, if you have a question, if you have answers, if you have a way to help people who are learning how to code, please join our Google Plus group. And they can find us at where?
bit.ly/twitcoding101.
Woot! Now, it's not just Google Plus. We're also on the Twitters.
Yes, we are. Yeah, so anytime you want to get a hold of us, if you're on Twitter, I'm at Snubs, right there.
Wait, and I'm here. I'm at Padre SJ, twitter.com/PadreSJ. Follow us and you're going to find out what we do when we're not here on the Coding 101 stream. It's a lot of fun and we really enjoy a conversation with you. Don't forget, we're live.
Oh, yeah.
Like right now.
Oh my God.
I know. Is this real life? No, every Thursday, 1:30 p.m. Pacific time, you're going to find us live.twit.tv. If you join us, you get to see the pre-show, the post-show, and all the bloopers in between. It's kind of a nice way to integrate yourself into the Twit army. Yeah. And as long as they're watching
watch
live.
That. Where is it? live.twit.tv, and we also have the chat room, which is where we pull questions during the live show. So if you jump in there and you have a big question about something, just say, "Hey, Snubs, Father Robert, what does this do?" And we'll hopefully get to it during the live show. That IRC chat room is irc.twit.tv.
Woot. Until next time, I'm Father Robert Ballecer.
I'm Snubs, Shannon Morse.
End of line.
Bye.
Okay, wait.
Everything is awesome. Oh my God. This is so creepy. Everything is awesome. That's why I only come in here once a week.
Everything is cool with the part of a team.